right, good morning. So it's my pleasure to introduce today's plenary speaker, and today's plenary is the AEESP Lecture. Our speaker this morning is Julian Marshall. He's a professor in the Department of Civil and Environmental Engineering at the University of Washington. And his research focuses on air pollution exposure assessment with specific focus on urban areas and the developing world. Julian has collaborated with a lot of AAAR members. He did his PhD research at Berkeley with Bill Nazaroff, and earlier this week, Julian told me that some of his thesis work on aerosol intake fraction was featured in Bill's plenary that he gave 20 years ago. So we're circling back a little bit to that. Julian was also the co-PI, along with Alan Robinson, of the EPA-funded Center for Air, Climate, and Energy Solutions. Julian's a leader in environmental justice research, and that's the focus of his talk today, which is entitled Anti-Racist Air Quality Anti-Racist Air Quality Modeling. And so please join me in welcoming Julian.
Good morning, everyone. Oh, it didn't work. Good morning, everyone. Good morning. Thank you for coming here this morning so early. I can assure you that my students would not be here this early for any of my lectures. Thank you to the organizers for inviting me here. Thank you to AEESP for inviting me as well, and thanks you all for being here. James Baldwin said, not everything that is faced can be changed, but nothing can be changed unless it is faced. So with that as a spirit, let me jump into this question of, there should be a question mark at the end of the title of this talk. What does this actually mean? I may share some thoughts, but I welcome hearing your thoughts on what this would mean, anti-racism, air quality modeling. So I'm going to open with a land acknowledgement. And as also I want you to think about not only kind of what the words are that are up there, but the systems of oppression that underlie kind of that we need to make this statement. And as well, a slavery acknowledgement. This is a part of our history. There is kind of deeply rooted mistreatment, violence, white supremacy that underlies this. And the systems of power that led to this and come from this kind of underlie the disparities in air pollution exposure, which is what I'll be talking about today. So it's important to start here with this. So everyone knows that air pollution is bad for us. I'm just sort of every day constantly surprised by what are the health effects of air pollution. And this is one of the main reasons why we study what we study. And what I want to argue here today is that the disparities in exposure are almost their own separate reason to care about air pollution, in addition to the kind of overall health effects. When my advisor, Bill Nazaroff, was here 2 decades ago, his talk was about exposure assessment, and it was focused on the metric he used, which is intake fraction, which you may be familiar with or may not be familiar with, but it focuses on the overall population average exposures. And so in some ways, this talk is a follow-on to that because we're trying to look at not just the averages, but the distributions within those averages. So I use this title, anti-racist or anti-racism. I use this term in my title, and this is a good definition of it. Here's this book. I recommend this book by Ibram X. Kendi, and I'm just going to read this out. A racist policy is any measure that produces or sustains racial inequity between racial groups. An anti-racist policy, in contrast, is any measure that produces or sustains racial equity between groups. And then here's the key part. This is the key part of his book. There is no such thing as non-racist or race-neutral policy. Being an anti-racist requires persistent self-awareness, constant self-criticism, and regular self-examination. So in his framing, there is no such thing as race-neutral because if you are ignoring the disparities that exist, then you are allowing them to persist. So I think this framing is kind of It's changed my thinking. I think it's changed the thinking of many people in engineering. It used to be, oh yeah, these were sort of societal problems. They were not our purview because we were studying air pollution. And I think this book helps us to recognize that we need to face what the disparities are and not merely allow them to exist unexamined. So there's 3 things I want to cover in my talk today. And I'm going to lead with my conclusions here. The first is that we don't all breathe the same air. Air pollution concentrations vary in space, as you all know, as there are many posters here to attest to. Those variations in space correlate with demographic attributes. And as you'll see, the biggest one they correlate with is race ethnicity. Second point I want to make is the past is present. A lot of the decisions that led to the disparity we see today happened long ago. And so these disparities are not something that anybody in this room asked for or selected, but they are just the way it is. And we have to talk about them, acknowledge that, and then talk about, okay, if we don't like that, what can we do about it? And the third point is the inequities will not eliminate themselves. If we want to reduce them, if we want to address this problem, we have to shed light on it and actually specifically find ways to address these disparities. So there's a summary of my talk. With that, let's start. So I think people by now have probably heard of redlining, which was a government-sponsored or government program that reinforced segregation. This is kind of an example of a top-down systemic racism. If you're unfamiliar with redlining, please go and Google it and look at your city or your favorite city. You will find explicitly racist language that will offend everybody in this room that was built in to where people could live, where they could get home loans, not get home loans. These maps exist. Of course, they're not the only examples of racist urban planning. There was plenty before redlining came along. There was plenty after it ended. But these maps were preserved today, so people kind of point to this as one example, even though there's other examples out there of top-down examples of this. And then the other picture I have is a bottom-up. These are racial covenants. So both these maps are for Seattle, where I'm coming in from, and a racial covenant basically said when you bought or sold your house, you were agreeing not to sell your home to somebody who was not a specific race. So this is sort of a one-to-one bottom-up example of systemic racism, which reinforced segregation. Now, the start of these policies is not in my lifetime. Let me just go back. Right? When these started, this is not my lifetime. This is not even my parents' lifetime. My parents were born in the late 30s. So this is like my grandparents' generation. Right? The people who implemented these are not alive today anymore. But the end of these policies, now that starts to get into my lifetime. So here in Washington State and Seattle, these ended in the late 60s and 70s when these were outlawed. I'll make 2 points about this. One is, so on the right, the Seattle Open Housing Ordinance, which was the ban against racial covenants in 1968. So Seattle is this, amazing liberal city, right? Few years earlier, the same idea was up, and it failed tremendously by a 2-to-1 margin. It was not until after Martin Luther King was assassinated that the city government just said, okay, we're not putting this up to a vote, we're just ending it right now. So, I think another point here, which this leads into, is that, of course, when these laws, kind of were ruled illegal, the racism that led to them didn't instantly go away. It was just ruled illegal. And one small example of this is after this was no longer allowed. This is an advertisement for a house in the Seattle Daily Times, pointing out that it's a restricted neighborhood, which should not have been allowed according to the laws of what was up there. Okay, so again, the main point is this happened long before any of us were born. We didn't ask for it. Whatever amount of systemic racism we see today, it was certainly much greater here with these policies. So with this as background, and kind of feeding into where we have segregation, why we have segregation today, what is environmental justice? Well, it's a term that means many different things to different people in different contexts. whether you're thinking about rural areas or indigenous lands or urban environments. There's many different aspects of what is environmental justice. When I go to the literature, this is kind of the way I subdivide that literature between kind of local issues versus systemic issues, and between processes versus outcomes. So if you are looking at the definitions that are kind of more based on process. Let's see if I have a laser pointer. Nope, okay, doesn't matter. If you're looking kind of to the bottom half, the processes are like, how are decisions made? Who has political power? Who has access to decision makers? And if that's the aspect of environmental justice you're thinking about, you'll see terms like fair treatment or meaningful involvement. Whereas if you're looking at outcomes, you'll see terms like undue burden or disproportionate impacts. In my work, and what I'm going to talk about today, I'm kind of in the upper right. I'm looking at outcomes, and I'm looking systemically. Now, the reason I look at outcomes is because I'm an air pollution researcher. I care about concentrations and risks, and I'm not really as much studying the process, the legal process. And I look systemically for the following reason. A lot of environmental justice research and scholarship is about what happens in any one specific location. And in that case, what is there really matters. The specific details of that location really, really matter. And what happens in one location oftentimes is unique. That's why it's important to study what happens locally. However, it's also the case that what happens in one location often is not unique. Certain patterns are repeated over and over and over and over again across our society. And so a lot of my work is trying to look systemically at what are the patterns that we see when we step back, not just at one location, but across many locations. It's funny, when I look at this timeline for the environmental justice history, there's many aspects here I could point to. And whether you consider this to be a long history or a very short history kind of depends on where you are and how many gray hairs you have. But to me, this is not a very long history, maybe because this was all kind of during my lifetime. The very beginnings of environmental justice in the US started about a decade after the major civil rights acts of the late 60s. So it wasn't until the late 70s that the first environmental-focused lawsuits came about, and Bob Bullard, who is still alive today and working as an academic, was an expert witness in the very first lawsuits coming out of Houston. He then kind of looked across the southeast of the US and published for the next decade and published his findings in this book, Dumping in Dixie, in 1990. I have my students read that book because there's a few reasons, but one is to kind of highlight. I mean, of course, this book came out before any of them were born, but it highlights how a lot of what we see today has roots historically and kind of makes that connection, and also because a lot of what he says, which was relevant in the 80s when he did his research, a lot of it is still relevant today, and it's really important to see that. The other thing I'll point out about this history is, so we had some lit reviews. The first lit reviews I can find were in the early and mid 90s, and there were a small number of studies then. There were a really small number of studies, kind of a little more than a dozen or a few dozen studies at that time in the 90s. And there's a bunch of reasons for that. One is just the focus of the research community and where it was at the time. But another reason is just the availability of the mapping software that it takes to study questions like these. It wasn't until the kind of late 90s that tools like ArcGIS became widely available. And then soon after 2000, you see this dramatic increase in the number of studies that are looking at kind of mapping and whatnot. So I began my PhD in 2000, and I was kind of part of that ramping up. So let me give you an example. Here's some work for my PhD. Now, so I was in my PhD from 2000 to 2005, and Bill Nazaroff came here in 2003 and gave his talk about averages. And so this is kind of soon thereafter. This is for Southern California, some work we were doing there, looking at exposure assessment, and we had about 20,000 individuals who had filled out a survey. We were measuring some exposure for them, modeled, and I remember I said to Bill, these are real people. We have their demographics. We should look at that. And what do you think we'll find? And what if there are differences? Like, how much of a difference is too much? He said, I don't know, Julian, just go and do it. So I did, and here's what I found. So, we didn't really know what we would find, and I guess what we found is perhaps not surprising and consistent with other work at the time. There were 4 racial ethnic groups in the survey that we had used. They are white, Hispanic, African American, and Asian Pacific Islander. We were looking at 3 pollutants: ozone, diesel particles, and benzene. Okay, so you can see here there's differences among subpopulations and differences amongst pollutants. White people have lower exposure to diesel and benzene, and the 3 non-white populations have higher exposure, whereas ozone is the reverse. All right, you all are air pollution scientists. Why is this happening? I didn't quite hear. They're away from the emissions. And for ozone, yeah, there's titration, right? So you have like opposite spatial patterns, exactly. The 2 primary pollutants have higher concentrations near source. So in the Los Angeles case, this would mean downtown Los Angeles and near major freeways. And so those are locations that have fewer whites and more non-whites. So that's why you have that pattern. Ozone, you have the reverse pattern because of the time it takes to form ozone, because of titration. And so the high concentrations are not downtown, they're not near the freeways. So you get this result, which is exactly what you would expect from the chemistry and physics of air pollution. Ozone is kind of this atypical example. So that was for Southern California. We were curious what other locations look like. We did a couple of things. One is we also did a literature review. So at this point, there are now many more articles than there had been in the mid-90s. And the vast majority reported higher impacts for racial minorities and low SES. SES is socioeconomic status. It's not all of them, right? It's not 100%, because if you study a bunch of areas, you'll find some exceptions, just like ozone is kind of an exception. But the vast majority point in that direction. That's one thing we did. The other thing we did is trying to kind of look nationally. At the time, there was not great information nationally about air pollution with good spatial precision. At the time, just like now, if you go to the EPA website and ask what's the air pollution where I live, usually you get this like multi-state regional look at air pollution. And that's not fine-grained enough to look at what you're seeing up here, which is near roadway versus not near roadway. So we need to develop a method for getting much better spatial precision. Same thing nationally. If you have kind of a CTM run, you're typically going to have, 32, 36 kilometer grid cells. Maybe you'll have 12 kilometer grid cells, but the national looks were generally kind of zoomed out. So we used an approach which is called land use regression. It's now quite common for getting good spatial precision. At the time, it had been developed and applied to a city at a time, and we wanted to look at what happens if you develop this nationally. And it turns out you can get models that work reasonably well. And so now there's many national land use regression, or they're also called empirical models. So that's what we did. We have predictions at the census block level, which is the smallest spatial designation that the census offers. These are publicly available. We have them through the center that Albert Presto mentioned. We have these estimates online. If you want census level predictions for criteria pollutants, we made these publicly available. Here's what we see for NO2. So this is for year 2000 and 2010, the 2 census years. On the left is just kind of the overall population distribution. These are box plots, so it shows the 10th, 25th, 50th, 75th, and 90th percentiles. The dot is the average. And then we have some different demographic groups by race, ethnicity, by income, education, and age. So I'll point out 2 aspects here. Concentrations got cleaner over time. They clean up by about 1/3 across this decade. That's great. That's good news. Also, if you look at the different demographic groups, everybody's air got cleaner. That's also the good news. And that's really important to point out and to celebrate. Thank you, EPA. Thank you, Clean Air Act. However, the flip side is that what disparities were there kind of tended to remain. The people who were more exposed tended to stay more exposed, and the people who were less exposed tended to stay less exposed. It's like, just imagine if you could take all the air pollution and magically cut it in half, everywhere concentrations go down by a factor of 2. So that's great, everybody benefits, and yet whoever was more exposed is still more exposed. In absolute terms, the difference between the higher and lower exposures come down by a factor of 2, and in relative terms, they remain unchanged. And that's kind of what we see here. The last thing to point out is, there are differences by various demographic groups, but really the differences are by race ethnicity. That's where you see the largest differences among subpopulations. The differences by other demographic groups, and we have others in the supplemental information, are just either zero or not as large as the differences by race ethnicity. And I'll come back to that, but that's a really important aspect of the finding. This is one way to look at the data. So here, the unit of analysis is the subpopulation. We're comparing among subpopulations. You can also do a similar analysis where the unit of analysis is location. So that's what this looks like. Here we have the same two census, census years plus going back one more census, so 1990, 2000, 2010. Same thing as concentration of NO2 air pollution. On the x-axis is the percent non-white in that community, in that census block. So for each line, the dot is the median, the thick line is the interquartile range, the thin line is the 10th to 90th, and then the dotted lines are the 1st to 99th percentiles. So each line just kind of shows the distribution. If you just follow the median, for example, that dot moves down and to the right over time. That's a reflection of the air getting cleaner, moving down, and moving to the right, our society becoming more diverse. And you see the same kind of general pattern here, the same conclusions as from the prior slide, which is the air got cleaner for everybody. That's the good news. And yet, so the disparities are kind of like the slope of that line is what you're looking at. And the line moves down, but there's still a substantial difference between the left and right sides of this line. In fact, if you look at the 2010, the right side is about a factor of 2 higher than the left side. So there's still work to be done. Now, one of the first questions I get on this research is, and these findings is, well, what about income? Because income correlates with race. How do you know that this isn't, merely, in quotes, merely race as a stand-in for income? And it turns out that's not really the case. So here's one example to look at that. I'm still sticking with NO2 air pollution. I picked out one year here, which is 2006. We have large, medium, and small urban areas. We just divided the urban population up into thirds, into tertiles, and then rural areas. On the x-axis is income. The y-axis is still NO2 air pollution levels. And then each line are one of the 4 main racial ethnic groups, Asian, Hispanic, Black, and white. So the differences by income are represented by the slopes. And there is a downward slope to the lines. It's not very steep, but it's there, and you can see it, especially in urban areas and especially in large urban areas. That's a representation of the differences by income. And the differences by race ethnicity are the separation between the lines. And you can see with your eye, if you read the text, it kind of gives examples, but you can see with your eye that the differences by race ethnicity are larger than, and by this display, statistically distinct from the differences by income. So this is not, quote, merely, race merely substituting for income. There are differences by both, but the differences by race ethnicity are larger than those by income. And in fact, if you look at large urban areas, your average concentration for low-income white people is actually lower than for high-income Hispanic people, for example. We're not the only ones who's found this. Kind of other literature also points to race is more important than income. That's for NO2 air pollution. Of course, each pollutant has its own story to tell. So here I'm showing maps for 3 pollutants. This is differences within each state. So the gray color would mean nearly 0 difference between whites and non-whites. It's plus or minus 5%. This is the gap relative to national average. Colors in purple mean higher exposures for non-whites. Colors in, a tannish color would mean the reverse. This is the same story as what I started off with. It depends on the pollutant, which indicates, kind of the spatial patterns. So NO2 is primary-ish. It has the largest spatial gradients. Ozone is secondary. It has the lowest spatial gradients. And PM 2.5, as everyone knows, is secondary and secondary. And so the spatial gradients are kind of in the middle, and the disparities are kind of in the middle between those 2 pollutants. I'll also point you to some work by Provat Saha, who's here, by Albert Presto, that looked at ultrafines. As will not surprise anyone, ultrafines have more spatial variability than PM 2.5. In terms of disparities, they look more like NO2 than like PM 2.5. Okay, so here's maps for those 3 pollutants. We made lots and lots of maps. If you like maps, I'm happy to talk maps. Here's a bunch of different pollutants, the criteria pollutants, across the different rows, and then the columns are, for each state, the average concentration for non-Hispanic white people versus state average, and then non-Hispanic black, then Hispanic, then non-Hispanic Asian, then kind of an overall representation on the final column and overall representation in the bottom. And of course, there's differences here, but the main point is there's no state for which EJ is not an issue. There's no state that, so in this color scheme, white would mean nearly 0, plus or minus 5%. There's no state that is whited out for all the pollutants and for all of the racial ethnic groups. This is a single pollutant look at this. You can also do a multi-pollutant look. So just to summarize here, in most states, 73% exposures are higher than average. I use kind of 5% as my cutoff. More than 5% higher than average for black people. For Hispanic people, it's 57%. For Asian people, it's 35%. And for white people, it is 0%. There are no states up there. So this would be the first column. There are no states where the first column is purple. It's all the color scheme. It's either white or tan. So white people either have about the same or cleaner air in all the cases we're looking at here, never dirtier air. The most exposed group is always a racial ethnic minority group. And then for a multi-pollutant look at this, here's one way to frame it. The proportion of the population living in a very polluted location, above the 90th percentile, for 4 or more criteria pollutants. So these are the most polluted places in the US. Some people might label these like the sacrifice zones. They're just really, really polluted. For multiple pollutants is about 5% for Hispanic population, approximately 2% for the Asian and black population, and about 0.5% for the white population. So here's a map for the US. I have one slide here on not the US. I had a student who recently graduated from China, and she wanted to look at what this looks like in China. So here's her results. We also did a land use regression empirical model for China for PM2.5 and NO2. We looked at this in many different ways, using different measures of SES. It's a little bit tricky because the census data are quite different. The meaning of SES, the meaning of race, everything is different in a different cultural context. And in general, we see basically the opposite finding for China as we saw for the US, which is in China, we saw higher exposures for higher SES. Why is that? Well, again, everything is kind of different in China. There's a different, all the context. But our hypothesis would be that given the rapid development that is happening in China, development correlates with industry and with income. And so you have higher income individuals, higher SES individuals, closer to the pollution. This is kind of a national look. We looked at individual states and provinces and urban and rural areas, and over again. We kind of saw the same pattern over and over again. And so I think it's a robust finding. And China's different. And I put this up here, so everything, economics, history, culture, urban planning. I put this slide in here as a reminder that what we see in the US, it doesn't have to be that way. It just is that way. It's a reflection of the history and context that we have here. And this gives me hope that we can possibly change that to the extent that culture is changeable. It's not just baked in that it must be this way. Okay, so I'm gonna shift a little bit. I'm gonna shift methods. So what I've been talking about so far are empirical models or land use regression models, and those tell us what is. What is in the sense of they're based on measurements. They are not great at telling us what could be. They're not great at asking what if type questions. And so I'm gonna shift now to mechanistic models. We use a model called InMap, which is a reduced complexity model. It's built on a conventional CTM, and then we develop InMap as a faster and lighter version of a CTM. I also want to shift to solutions because I'm an engineer. I want to solve problems. I don't just want to study the problems, I want to study the solutions. If this is a problem, okay, what can we do about it? How can we change things? So to change things, it's require a lot of expertise. It's not just one person in their own room trying to solve the problem. It's many people around a table. We need lawyers, we need economists, we need people from policy, et cetera, and we also need engineers to work on the models that will answer the question of, okay, what do we actually do? How do we reduce the emissions to address disparities? And so I'm tracking kind of a quite familiar causal chain here, from emissions to exposures and so on. So when we did that, so we're using this kind of reduced complexity mechanistic models based on chemistry and physics, looking at the different sources of exposure, right? We think in exposure science and engineering, if you want to improve the air, there's only one solution, which is to go after sources. You have to reduce the emissions. So here we've subdivided the emissions into 14 different sectors, industrial, coal, electricity, and so on. Each different sector of the economy has its own spatial signature of where that pollution is. And in one of the first studies, we collaborated with economists to look at who consumes the goods and services that lead to this pollution. Okay? In a conventional framing, if there's a factory and it's polluting, then you'd say, well, the factory is, quote unquote, responsible for that pollution. You tag the pollution to the factory. And what this economics framing does is it says, let's say the factory is, making pens, and I bought the pen. So it asks who consumes the goods and services that led to that pollution. The factory is not polluting for its own sake, it's polluting because of some economic activity. Who's doing that? If I bought the pen, in this framing, I'm quote unquote responsible for that. That's kind of the framework that's here. So we divide that up into end use economically, and then the surveys that were used here had 3 racial ethnic groups: Black, Hispanic, and everybody else. So I label that as white/other. Those are the 3 groups. Then we have spending by government, and then we have kind of exports. Those are separated out. So this is kind of the inputs to the model, to the effort. The outputs have 2 parts. Here's the first part, is the concentrations and the exposures. So here's the same 3 racial ethnic groups: Black, Hispanic, and white/other. This is for PM 2.5. There's the population average. This will surprise nobody who's been paying attention so far to this talk. Exposures are lower for the white/other and higher for the Black and Hispanic populations. What's different here is it's a mechanistic model, and we can track it back to the sources, which sectors of the economy led to that pollution. So that's the first half. The second half, and this is kind of like who's consuming the goods and services that led to the pollution, is basically the opposite. It's the opposite. So on the right-hand side, the sorry. Loud, I'm sorry, it's so loud. On the right-hand side, the white/other group is consuming goods and services that lead to more of the pollution, and the Black, Hispanic groups are leading to less pollution. So this is like the flip side. It's the opposite side of the coin, not the exposures, but who's quote-unquote causing the exposures. Now, I mentioned already that the left half, the exposed, is not really an economics story. It's really kind of differences by race, ethnicity that are separate from those by income. Whereas in contrast, the right side of this plot is primarily an economic story. It's that there's greater consumption by this third category than by the first 2, and that leads to the higher levels of kind of responsible for pollution. If you look at the basket of goods and services consumed, it's a little bit different, but it's not very different. That's not really the driver. The main driver is just different levels of consumption. So we looked at this result, and again, we have different sectors of the economy, different emission sources, and we thought, okay, so what we need to do is figure out which sectors of the economy are most responsible for the disparities, because then the policy implication would be quite straightforward, quite obvious. Target those sectors of the economy if you want to address disparities. So that's what we did. That was the next paper. And it turns out that that framing, it's actually quite naive. It's not like that. There's not just 1 or 2 or 3 sectors of the economy that are responsible for the disparities. It's kind of like all of them. So here's the results that kind of show that. So here we have the same 14 sectors of the economy. The first column is for white people, then everybody else, which we labeled as people of color, then the 3 largest subpopulations within that column, which are Black, Hispanic, and Asian. In red, would indicate higher exposures for that sector of the economy, and blue would indicate lower exposures from emissions from that sector of the economy. And the point of this slide is, when you look to the right side, there's a lot of red. It's not just one or two sectors of the economy, it's nearly all of them. The two exceptions, at least for the second column, are agriculture and coal electricity. Those are emission sources that tend to be primarily rural. And rural populations in this country are greater percentage white than urban populations. So that's why you have these two exceptions. For the other sectors of the economy, they're all red. And in fact, when you go to the third column, for Black Americans, all sectors are red. All sectors of the economy lead to greater exposures. It's almost like it was planned that way. So, thank you. She said it was. Another way to say this is systemic racism is systemic. It is systemic. There's thousands of different sources that are out there, and when they went to locate wherever they did, there's a million different reasons why they happened to locate there. But there's kind of this outside forcing function, which is they are more likely to locate in and upwind of Black and brown communities. Why? Well, one main reason is political power. If nobody wants that source in their backyard, then groups and locations that have less political power are less able to fight against that. And all of that is what underlies these results. So our core conclusion here is actually most emitter categories yield unequal exposures. It's not just one sector of the economy. Now, the plot you're seeing here is US-wide. And we tried subdividing this in many different ways to see if there was like one thing driving it. And it's not. It's just a pattern that gets repeated over and over and over again. So we looked individually by state, we looked by urban areas, rural areas, by income level, by exposure level. We see the same thing over and over and over again. So when we finished with this paper, we thought, okay, actually it's not going after different sectors of the economy. I mean, within the Clean Air Act framing, that's kind of what the MACT and BACT type standards do, is they pick a sector of the economy and they say if you're larger than such and such amount, you have to reduce your emissions. Mobile sources, we've got all kinds of pollution on mobile sources. I tend to think of sectors of the economy because that's how the air pollution control classes are set up. And this suggests that framing is not going to get us there because it's going to do the same thing kind of like what we saw before where you just cut the pollution in half. That's great, everybody benefits, but you leave the disparities in place. So when we finished this paper, we thought, okay, well, what about, here's our hypothesis, what about location-based rather than source-based or source category-based emission reductions? So then that's the next thing we turn to, and here's some results from that. So let me just focus on the first plot here. In each of these plots, the x-axis is the cumulative emission reduction. Okay, so you start off on the left side, and there's 0 emission reduction. That's kind of right now. And then as you move to the right side, that's basically 100% emission reduction. Okay? And then in the first plot, the y-axis is disparities. And so you start at the upper left. That's the difference. The upper left is a difference in exposure between the most exposed racial ethnic group and the overall population average. And if you were to just take all your emissions and ratchet them down, reduce them 1%, then 2%, then 3%, all the way down to 0, you'd go down along that dotted line. That's one option. And then we looked at 3 archetypal policies, 3 ways of approaching air pollution. One way is by sector of the economy. And we did this as an optimization. So we said, what if you take the pollutant and sector of the economy that will lead to the biggest benefit for reducing disparities, and you reduce those emissions to 0. And then you take the second best combination of pollutant and sector of the economy, and you reduce it to 0, and you optimize your way forward. What would that look like? Of course, any real policy will not hit that optimal, but we just want to say what's the best you can do with that framework, that way of thinking about the problem. We also look at NAAQS type standards, right? Everyone knows how the NAAQS works. You have a set of standard, and then if you're violating that standard, the region has to reduce its pollution. That's the NAAQS. That's in orange. The one I described already, the optimization by sector, is in blue. And then the last one we looked at is by location, optimization by location. We go to the location that will give you the biggest benefit to disparities. You reduce the emissions there. Then you go to the next location. This is optimization. Go to the next location that has the best benefit, then so on and so on. So what you want to see in this plot is the y-axis values dropping to 0 quickly. You want to deviate from that black dotted line, which is, the black dotted line is sort of like, don't worry about this problem. I mean, you certainly want to not be above the dotted line. Then you're doing worse than just reducing everything. So what we saw is that the NAAQS approach kind of sticks close to the dotted line. It does deviate from it a bit towards the end. but it does not give us a y-axis value of 0. The blue line, the optimization by sector of the economy, can get to a y-axis value of 0, but you have to go a far way to the right. You basically have to reduce your emissions to nearly 0, and then you've eliminated the problem. So we'd say the NACS doesn't get us there. The blue line does, but it takes a while. Whereas in contrast, the green line gets you there overnight. It gets you there quite rapidly by going to the locations that matter. And so that's our location. That's our summary of this result, as it says at the top: location, location, location. If you really want to address the disparities, go to the locations that are causing the most to those disparities and reduce the emissions there. Now, in many ways, this conclusion is not new. This is the same thing that overburdened communities have been saying for years, for generations, which is fix the air pollution in our neighborhood. This is the problem. And here's some modeling results that is consistent with that request from overburdened communities, and also suggests that what's right now the main approaches we have in the Clean Air Act, which are NACS and MAC-BAC type standards, probably won't get us there. In some ways, that should not be surprising. When the Clean Air Act was passed in 1970, these issues were on nobody's radar. So the Clean Air Act has been marvelous and done lots of good things for improving air pollution, and it was not asked to address disparities. Okay, so the last bit of research I want to talk about that followed on from this is like, okay, so how would we do this? And then the Biden administration came out with their Justice 40 approach, which says that they're going to put 40% of the benefits from addressing climate change into overburdened communities. And they came up with a tool, which is called CGIST. It's the Climate and Economic Justice Screening Tool, which selects communities. Right now, it's basically binary. It's a census tract. Either you're in or you're out. That's the current framing. And they want to put money into communities that are identified in the CGIST tool. And so we thought, okay, great. This is a location-based strategy. Let's take a look at what does this mean. So I have 2 slides here. This is kind of going forward. We started with a business as usual. What's going to happen out into the future? And here in this framing, we just looked at what's happened in the past in terms of emission reductions over time. First, just looking kind of business as usual. What if we extend those out into the future? So here we have 3 different kind of framings on this. One is, are you a Justice 40? Actually, we should say a CGIST community, or they're called DACs, disadvantaged communities is the terminology there. So you see there's differences between DACs, between disadvantaged communities and non-disadvantaged communities. There's differences by race, ethnicity. There's differences by income. When we look into a business as usual, just forecasting out to the future, we don't see these disparities going away. You know, if you keep doing what you've been doing, you'll keep getting what you've been getting. We also see in this modeling approach the same things I've talked about so far, which is the largest differences are by race, ethnicity. And then what we did in the model is we said, okay, what if you implement this location-based approach? What if you accelerate the emission reductions in disadvantaged communities? Then what happens? So we tried 2 things. One is we doubled the emission reduction rate in disadvantaged communities. And the next thing we did is we quadrupled the emission reduction rate in disadvantaged communities. So we call that aggressive and very aggressive emission reduction in those communities. Okay, so here's what we see. The top line is absolute disparities, so differences in terms of micrograms per meter cubed. The bottom are relative disparities, differences in percentage terms. The initial bar, the sort of white and black, is the current level of disparity. Then the next bar is under a business as usual in 20 years. And then we have the aggressive and very aggressive emission reduction approaches. Those are kind of our 2 policy alternatives. The first column is for Justice 40 communities versus the overall population average. Then we have for people of color versus the population average, most exposed racial ethnic group, and then low income population. So what we see is, when we look out into the future, the differences for Justice 40 communities on the left side and for low income populations on the right side, those are smaller to begin with. These policies are effective at addressing those disparities. When we look 20 years into the future, those disparities go away with the policy, not without it, but with the policy, or they actually turn negative from this forecast out. Whereas in contrast, the disparities by race ethnicity do not go away. And in fact, if you look down at the lower plot, so this would be F and G, the lower middle, disparities in percentage terms, not only do not come down, but in many cases they go up in percentage terms. Why is that? Well, there's a bunch of reasons why. I mean, this is just one lens into the future. You know, the future is not decided yet. I think we have control over the future. We can deviate from this. But here's two answers to why. One answer that you'll hear, and this is correct, is that when setting up the CGIS communities, disadvantaged communities, the current administration did not include race. That was a very deliberate decision because they were concerned about getting sued. I'm not a lawyer, but my understanding is that you're not allowed to use race in determining how federal dollars get allocated. And so it was a deliberate decision there. And some communities would say, I mean, that's kind of a debate. I guess I won't enter that debate, but just say that's kind of up for debate is what we should do about that. That's one answer to the why. But I think if you view this as sort of a critique of the current administration, that's missing the bigger point. Because the administration is there, at some point it'll be a different administration, then a different administration, then a different administration. The other reason why I think is there are not great tools out there to do this. This is not part of what people do in regulatory impact assessment. It's very different from meeting a NAAQS. Right? If you're violating a NAAQS, everyone knows this process. You have to come up with a plan, a state implementation plan. You have to show with modeling, everyone in the room loves this, show with modeling, at least all the modelers, how that plan will get you into compliance. And then you make measurements over time. You see how it's going. So that is a level of accountability. Because you can't just say, oh, we're going to encourage carpooling. That's how we're going to meet our standards, and then you'd be done. And then everyone says, well, carpooling is good. That's probably going to solve the problem. No, you have to model. You have to show, okay, how much of a difference is this going to make? And then you're going to find very quickly you can't just encourage carpooling and plant trees and solve air pollution problems. It's a much bigger problem than that. So within the NAAQS, we kind of have figured out that accountability. And what I want to offer here today is within the EJ disparities, we need that accountability. We need modeling that can show this kind of thing, which is to say, if you make changes in policy, if you make changes in emission, not only what do we expect are the changes in average concentrations, that's kind of what our models currently can do well, that's the state of the science, but we also need models that can look at disparities. And so one of the reasons why I'm here is to argue for that. Look at the models. If the models are not designed to investigate disparities, then they will not shed light on the disparities. And if we want to shift to focusing not only on the averages, but also the disparities, that's going to involve some changes in the models. They might need to have better spatial precision. So the model we use here is InMap. It has better spatial precision nationally than conventional CTMs. I'm not here to argue specifically for InMap. You can like it or not like it, use it or not like it. It's not about the model. But I will argue that we need to think about whether the tools we use obscure or shed light on disparities, because they are their own separate aspect and are important for looking at also. And we won't be able to address them unless we shed light on them. So I hope this is a call to action. If we don't want this to be our future, then we in the modeling community and the measurement community need to come up with better tools that will allow regulators to shed light on these topics. So a couple concluding slides. This is the first one. This is kind of the main points of my talk. We don't all breathe the same air. The past is present. A lot of the reasons for the disparities we see lie not only in the present, but also in the past. And then from this last thing I just showed, the inequities will not eliminate themselves. If we just ignore them, they will not go away. Closing thoughts and takeaway. So I already said this, the disparities are an additional reason to care about air pollution. The main causes are differences in political power, it's segregation. Here's what I think is needed. Number one, studying the solutions, not just the problem. We want to focus on solutions, look for win-wins, where can we address other problems also in addition to the disparities, and then engagement with and listening to community groups, leading with voices of overburdened communities without doing so much that we're asking them to solve the problem. Because in many cases, what a solution looks like is something that would be challenging to all of us in this room. And so we don't want to expect community groups to have to be PhDs in air pollution science to solve this. We have to work together to come up with solutions. And to our friends at EPA or other leadership positions, next steps sort of acknowledge and shed light on this, which I think EPA is in the process of. I think we need more location-specific policies. Many states are doing this. I don't know if the leadership may happen at the federal level, it may happen at the state level. Many states are starting to do this. I think that's really important. And I would love to see some sort of commitment, some sort of target that we can see if we're meeting, just like we have the NACs. And so everyone knows how are we doing. We want some target and then say, hey, we're going to eliminate this, just the way the NAC says we're going to eliminate this. So with that, thank you to you all for being here. Thank you to my many co-authors. I believe Sunny Ivy is here, although there she is. And if there's anybody else here in the room, thank you for being here. Thanks to you all for listening, and I'm happy to take questions.
All right, so we have some time for questions. Again, please use the mics in the aisles and introduce yourself before you ask your question. And while people are thinking of their questions, all right, we have one right away.
So here is a novel concept. In environmental justice, which some of us lecture on it in the 90s before you started graduate school, it was very clear that we have a problem with scientists accepting science from people of color. Now, I've been in this business for a long time. I'm a Stanford graduate, first Chicana to ever get a PhD in environmental engineering, #1 in the country at the time, and not so much so now, I'm not sure, but it doesn't matter. I also did a postdoc at Harvard in School of Public Health, trying to avail myself of all the tools that I needed to solve the problems of my people and the people that lived in the neighborhoods that I knew of. I am an expert in indoor air quality because there was nothing going on about clean cars when I wanted to do that. That was really what I wanted to do when I went to Stanford. Anyways, that wasn't happening. Now it's happening 30-some years later, too far. One of the things that I found in all of my studies, because I've done a lot of studies, and I'm one of those people that I want to solve the problem, I just want to take another measurement, because that's the livelihood of many people in this room. It is about solving the problem for those of us who come from those places, because that means the lives of our grandmothers, our children. In this pandemic, many of us lost people while the scientists were running around trying to get money. It really hurt me a lot, because what I've done for decades was to educate myself to be able to solve these problems. So I've done deposition, indoor air, bioaerosols, health effects, everything that I need to know to solve the problem. And at the end, it didn't matter, because I was in an institution that does not accept my excellence, but gladly accepts the excellence of the students that I graduate, because they're all white. So this is my plight now. Environmental justice must, at its core, include the injustices perpetrated and the violence perpetrated against scientists of those communities, those EJ communities everybody now wants to help. So without that discussion, we're all just doing the same thing over and over again. If you are not willing to accept my excellence, which is real, and another thing, just closing, because this is the discussion that needs to happen. The disparities will continue because the hatred is so embedded in everything that is done. I fought for the university for 4 years, and at the end, they will not pay me for something that I did, that I earned. It is the same experience that a lot of Mexicans get when they do the cleaning, they do the gardening, they do the construction working, and they don't get paid. That's what happened to me. I did not get paid after I did my work, and they were willing to erase this entire community in order to do so. You are irrelevant when it comes to them to give me my paycheck. So that is, to me, the crucible of it all. Because we are allowed to get educated, go back to our communities and solve these problems, because some of us are engineers. I am a real engineer. But if I'm not allowed to do it and I have to wait for somebody like you to do it, you do not have not nearly as many tools as I have. And by the way, I'm just going to close with this. So I left Boulder, Colorado, because that nauseous hatred air in that place is so much worse for me than the air pollution that I'm breathing now in San Diego. I happily breathe that. I moved to National City specifically. I want to be with my people breathing that dirty air because that is healthier than the horrible hatred that I experienced in Boulder, Colorado for 12 years. Thank you very much.
Thank you for those comments. Thank you for your excellence. Thank you for your research. I would agree with many of the things you said, and just to amplify one of them, community-engaged research is its own thing. And if that is something you do not do right now and think is important, I would encourage you to reach out to this speaker or somebody else who is engaged in that, so that by aiming to do community-engaged research, you do not do damage to the community. Communities are busy, they have lots of other things to do, and air pollution is merely one thing on a long list, and air pollution is not at the top. And so I think that's really important to remember as air pollution researchers. If we're going to engage with communities, talk to people who've done that before about what works and doesn't work. Don't just reinvent the wheel and start off doing it. Yes, please. Thank you for those comments.
Hi. Firstly, thank you for the wonderful talk. I really enjoyed it. And I want to address your slide when you were showing NAAQA's line. So basically, that line comes really close to the dotted line. And my question is, basically, this is the result of the policies which implemented by white majority, and the goal of this policy is to maintain status quo. How do you think it's possible to shift it so it would be closer to the line which you projected, like the green or the blue one?
It's a great question. I don't know the answer to that, but we're trying to figure that out. You know, when I think about the NAAQS, before we did this work, the NAAQS basically says where the concentration's too high, reduce those. Address the places where concentrations are too high. And that initially sounds like an equity-based approach. However, the way it's implemented is pretty broad spatially. It's by county or by CBSA. These are kind of broad spatial areas that all have to reduce their emissions. And so, yes, you go to locations with high concentrations, but you go to the whole region. That's the way it plays out politically, and reduce the emissions everywhere instead of finding the more specific locations, which is better for overall averages, but not for addressing the disparities. But can the NAAQS be used to also address the disparities? I don't know. We're trying to figure that out. If anybody in the room has answers to that, I'd love to compare notes.
Thank you.
Yeah, thanks for the question.
Hi, my name is Simone Balachandran from the University of Cincinnati. So first of all, I really, really appreciate your talk. It's been a long time that we've needed a talk like this at AAAR. So you mentioned something really interesting, that you showed a timeline of the environmental justice movement, and much of it started in the early 90s. And but it's taken, a long time for it to be really taken as a rigorous subject within environmental engineering. So along those lines, and assuming that there is going to be a 20 to 30-year lag, because I was involved in environmental activism back then, and we were kind of screaming about environmental justice, and it just wasn't really taken seriously. So along those lines, I'm kind of doing a thought experiment, and there is this concept out there now in activist communities, and the concept is one of green colonialism. And so what that means, to provide a very simple example, is that if we really think about it, one way, an efficient way to get to 1.5 degrees Celsius is for technologies in higher income countries that reduce our carbon footprint, but that requires precious minerals from the global south. And so what I think will happen in the concept is, again, called green colonialism, and that is that we are going to engage the first world, higher income countries are going to engage in policies to extract resources from lower income countries to lower our carbon footprint, while at the same time maintaining their current standard of living. And I think those countries are starting to push back against that. So I think there's the geopolitics of a lower carbon footprint are already very significant, and I think they're going to, it's very possible that on a global scale, we're just going to reinforce this legacy of colonialism and extraction of precious resources. So we can look at cobalt in the Democratic Republic of Congo. We can look at lithium in Bolivia, two countries that we've had a long, there's a lot of compelling evidence about the nature of our interventions in those countries. So do you know, along these lines of environmental justice, have people started looking at this rigorously at sort of a more fundamental level?
Thank you for the question. I guess the best answer I'd say is no. That's not my area. So it's so loud. Environmental justice is a big topic. Lots and lots of important aspects of it, including the one you mentioned. I should probably stick to my lane, which is I'm kind of a researcher in the upper quadrant there of systemic outcomes for air pollution, primarily in the U.S. And there are many other aerosol-relevant environmental justice topics that are worth focusing on, like the one that you mentioned.
Thank you. I had a feeling you would say that. I have a lot more to talk. We should.
I look forward to.
Thank you. I really, really appreciate this talk. It means so much to me. Thank you.
Thanks
So
for being here.
I'm going to break in really quickly. We're running a little bit late, so we'll take one more question so Suresh and Cliff can decide who's going to ask. And then Julian will be here, I think, throughout the day, so you can catch him at the breaks.
Yes.
I'll ask a quick question, so Cliff can also maybe ask. Suresh Daniela Clarkson. I'm just wondering, how do you constrain these solutions such that in the end you might solve the environmental problem but might actually make the economical problem, for example, worse? Just as a very old example, coal workers, when you shut down coal mines, in the end they felt they were worse off because they had nothing else to do, lost a purpose in life. So I'm just wondering, some of these solutions, the easiest ones, might actually be the easy to cut on the environmental problem, but might actually have a bigger social problem.
Yeah, I'll keep my answer short since I know we're running short on time, but the modeling that I described does not include the economic impacts. And I agree with you that those are important.
Great. I'll make this really quick. I'm Cliff Davidson from Syracuse University. And first of all, I really want to thank you. This was just wonderful information. One thing that I think some of us would like to hear about is the reactions that you have gotten to this kind of data from different communities.
There's a lot of communities that are out there. I think in terms of overburdened communities, some overburdened communities are not interested. It ranges. There's no way to generalize, right? Just like people are different, communities and community organizations are different. Even two different organizations from the same community may have a very different philosophy. So some community groups are not interested in science. For me, I'm an outsider. I'm an expert. There's not really a distinction between being an expert and the government and industry. It's kind of a group of people who are not listening to their needs. And that's not a place for me to usefully engage. And some community groups are the other extreme, which is like they want science. They see science as a way to influence policy. What else? The other thing that comes to my mind, the other extreme from community groups is sort of leadership. I'd say I've talked with many, many people at EPA who agree with these comments, including the gentle critiques of EPA, of what things I believe EPA needs to also include. It can be hard to hear criticisms from your friends, but I think many people at EPA recognize that these are issues that need to take a greater role, and they recognize the challenge of doing that. It's easy to say it, but it's hard to actually implement that in a large bureaucracy. In terms of even higher up, I've been told I should wear as a badge of pride that we've been critiqued now by 2 White Houses in a row. So when the first one came out, some EJ studies, apparently the former administration, President Trump and his son were watching Fox News, and they did a series about kind of how air pollution is racist. And Trump tweeted about whatever had happened before that, and his son tweeted about his displeasure about racism and air pollution, whatever he said. And then recently we're kind of critiquing the Justice 40 CGIST approach, and the current administration also said, okay, there's this problem with the modeling, and I won't disagree with that. I won't fault them for needing to defend what they've done, and I know it's hard to do. So I've been critiqued by both Republicans and Democrats, indication that I'm trying to keep up the middle. I think in general, community groups want solutions. That's what I'd like to end with. It's like not just what is the problem, although documenting the problem has its place, but what can we do about that? And that is a really big problem. And so that's what I want to encourage everyone to think about is what can we do about this? Yeah, thanks for the question.
Great. All right, thank you so much, Julian.